All right, so now we're going to use our log properties to solve for x. So if I want to undo the ln, I'm going to take e of both sides. So put both sides up in the exponent. This side turns into this sign turns into x, and this is e to the negative 1. That's a fine answer, or you could write it as 1 over e. Up to you. Before I go take the ln of both sides, I'm going to suggest that you divide through by the 2 first. Then go take the ln of both sides. So this ln and this e cancel, so I'm left with a 2x plus 1. ln of 5 is a number, so just leave it, carry it along. So then subtract 1 and divide by 2. And that's a number that I don't want a decimal, just leave it just like that. All right, to undo this ln, I want to take the e of both sides. So I have e to the e power. So ln and e cancel. So I'm left with e to the e, which is a number, and then subtract 2, and that's your answer. Let's see, sorry, e to the e minus 2. Oh goodness, what about this one? So I see there's a factor of e to the 2x in both of these. So if I factor out the greatest common factor, then set each of them equal to 0. E to the 2x is never equal to 0. A couple different ways to think about that. You could think of the graph of e to the 2x, which would look something like this. It's never have a y value of 0. If you tried to take the ln of both sides, you'd get ln of 0. So from here, you have no solution. From here, move the 2 over, take ln of both sides, and then divide through by 2. All right, so here, this e is up in the exponent, so let's go take the ln of both sides. So ln of 1, you know ln of 1 is 0, so use it. This e and ln cancel, so I get e to the x minus, oops, no, it's not the exponent, e to the x minus 1, minus 1. Move the 1 to the other side. Then take the ln of both sides, so I get x equal ln of 1, but you know that that's 0. So now I have 3 terms, so there's not a common factor, but just like when we had in sines and cosines, I do believe this will factor. So e to the x times e to the x is e to the 2x. So I think minus 3 plus 2 works. So e to the x minus 3 is 0. E to the x plus 2 is 0. E to the x is 3. E to the x is negative 2. Taking the ln of both sides, I get x is equal to ln of 3. If I try to take the ln of both sides, I have ln of a negative number. This gives me no solution. So one answer. This has e to the negative x. That's not going to factor. I'm going to be saying a lot this year. If you see negative exponents, put them in the denominator so you can see what they are. And I think I want to get rid of the fractions by multiplying both sides by e to the x. So I get e to the 2x minus 12 minus e to the x equals 0. So if I rewrote this, descending powers, I think this will factor, right? E to the x minus 4 plus 3. So e to the x minus 4 is 0. E to the x plus 3 is 0. E to the x is 4. So that gives us x equal ln of 4. This is e to the x equal negative 3. That doesn't work. Okay, here, again, I want to get it equal to 0 so I don't lose any answers. I could factor out an e to the 3x. So e to the 3x is 0, gives me nothing. And then e to the 3x equal 4. Taking ln of both sides and then dividing by 3. Okay, so this one here looks very similar to this one. the p, q, and r are constants. It looks very much like what I just had. This is going to be harder to factor out, though, because I don't know what the q and the r. So this one I'm going to suggest we divide. So let's divide both sides by e to the qx. So I get this. So this left-hand side here can be rewritten as px minus qx up in the exponent, because I subtract exponents when they're divided. Now let's take ln of both sides. ln of r I'll just leave as a number. Factor the x out, and then divide. All right, one last problem down here. So just making sure we combine everything we know about domain. So I know the denominator can't be 0, right? Denominator can't be 0. So I know that ln of 1 equals 0. So I cannot use x equal 1. I also know that the domain of ln, when I have ln of x, x's have to be bigger than 0. So x's have to be bigger than 0. And I can't use 1. So the combination of those two things gives me the domain. So here I know that since it's a positive root, since it's the fourth root, it has to be positive inside. So it has to be bigger than or equal to 0. So if I take the ln of both sides and then solve for x, I get negative ln of 2. Negative ln of 2 is less than or equal to x. I'm sorry, said that wrong. Yeah, no, negative ln of 2 is less than or equal to x, or x is bigger than or equal to negative ln of 2.